My
This
audio here is
conference will now be recorded.
Hello, welcome to the HPC project call. I see 11 people on, or maybe 10 of us now. We have a brief agenda today, but two things that need consideration. First of all is a new topic coming up from the rack and server group. So let me go back and take a quick look at that meeting notes here and introduce that. While I'm doing that, could somebody else speak up so we can make sure that the web conference is working?
Yeah,
it's working.
Okay, great. Shoot. All right. Is Alfie Liu on?
Yeah, I'm here. Yep.
Did I pronounce that right?
Yeah, that's right.
All right, good. Let me go ahead and bring your presentation up, and we'll go with you first on the agenda, and then Bapi will do your topic second. We'll review the feedback, and then we'll discuss third topics after that. I'm going to bring the PDF up and share my screen here. All right, and in 1 second.
So I'm gonna start saying a few things, and then I'll pass it over to our senior engineer, architect Han Wang, who is also in the call. So basically, what we're trying to do is to present the design of a GPU expansion box, and so this was done actually originally for ODCC. And that means it has been deployed in volume, and we have made some changes to it to accommodate the OCP Open Rack. So it says Open Rack compliant based on some customers' demand, and so that's what we are trying to present. So this is going to be contributed. Contributing to OCP, and we have already signed the CLA as the contribution agreement, and then we will be submitting the spec for it soon. So with that, I'll turn it over to.
So hold on, for the audience on the phone, then I guess your motivation here is to solicit feedback from the HPC group on this offering. Is that correct?
Yes, also, yeah, that's correct.
Okay, so I should probably, as the minutes for this go out, do you mind if I include your email address for that feedback?
Sure.
Okay, very good. Sorry for interrupting. Go ahead.
Okay, so I'll turn it over to Han Wang.
Hey everyone. So can you share the PDF file? I have a problem to share on my desktop.
Are you not able to see the screen right now?
I can see the screen now.
Han, I've given you producer rights if that helps.
Okay, let me try one more time, because from previous experience, I have some problem to show my monitor. Yeah.
Alfie, are you able to share if Han's not able to pull it up? There we go.
Okay, there we go. Yes.
Can you see the?
Yeah,
yes.
we're good. Yeah.
right, so if everyone can see the PDF file, I'm gonna start. So my name is Han Wan, and I'm the senior architect in Inspire US. So today I will give a brief overview about our JBox solution. The code name is called Mission Bay. So first, a very high level introduction on this solution. So this Mission Bay is a 3U box, which we designed for deep learning and then high performance computing. So it has 8 NVIDIA GPU and also have an optional CMC board, which can provide PCIe switch management. Also, we have 6 PCIe slot, which is by 16 PCIe slot, so which provide a very high flexibility to allow this box can have different connection topology to the host and also a flexible combination of high bandwidth card to the public domain through data network, or we can have a combination of general purpose GPU and the acceleration card. Also, if we want low latency to scale out the performance domain, we can use the InfiniBand and card. Also, we can scale out to multi-chassis to allow GPU clustering. So in this overview, I'm gonna briefly go through the system diagram and the major board. I will go very briefly on each small board, the diagram, also the ME part. So can you, next page. So from front view of the chassis, we can see the CMC riser card, and we have 6 PCI slots. So we also have the BMC management port, also reset power button and UID. So from the back, so we can see there's 4 9256 fan module provide cooling. We also leverage the busbar clip to provide power. So for the system topology, so at the top of this slide, you will see the CMC board. So this CMC board is leveraging Intel Atom 32350 processor. And so this board is majorly provide PCIe switch management. So at the bottom of the slide, it shows the GPU board. So we see there are 8 V100 GPU cards, and we have 3 PCIe switch, which has 96 PCIe lane. So we also have 6 by 16 PCIe slot. So on the GPU board, we also have the 8-speed 2500 chipset as a BMC. So this provides the onboard management. So I will go through the connection topology in later slides with a big picture. So this is a close look of from the top view about how the chassis looks like. So on the left-hand side is the GPU board. So we'll see the CMC board and the 6 PCIe slot and 3 PCIe switch. And in the middle are 8 GPUs. On the right is the PDV board, which is responsible for fan control and power distribution to the GPU board. So this is PCIe slot numbering. So we have 3 PCIe switch, switch A, B, C. So slot A0, A1, B0, B1 is connected to the switch A, and slot A2 and slot B2 is connecting to switch B and switch C. I will tell more details in next slide. Yeah, so we are leveraging a connection to bridge 1. So you can see on the right-hand side, we have 8 NVIDIA GPU. So the infrastructure is leveraging the hybrid cube mesh structure, which the peer-to-peer link is NVLink 2.0. so which delivers 300 gigabyte per second peer-to-peer communication. So which is 88% more compared to NVLink 1.0. So it's a dramatic improvement on the peer-to-peer communication. So each GPU has dedicated by 16 PCIe connection to switch B and C. Meanwhile, these two switch has separate by 16 connection directly to slot A0, A2 and B2 also has dedicated by 16 PCIe lane to switch A. The switch A has 4 by 16 PCIe lane to the rest of 4 PCIe slot. So if you look at the whole chassis as a standalone universal building block, so for this topology we have advantage. We have 4 PCIe topology connection inside the box, which means we don't need to rely on external PCI switch fabric to make point-to-point, slot-to-slot connection. So this 6 PCI slot can provide a very high flexibility. So we can connect the GPU box to the head node with balanced design. We can allow the high bandwidth card to the public domain. We can also allow to multi-host and do scale out to multi-chassis to allow GPU clustering. So the next page, this is a single dedicated by 16 PCIe lane to single node, head node. So this is a multi-node. Of course, we can also scale up to more chassis. So one of the advantages we have average lower latency compared to other solution. Yeah, so this is close view of GPU board. We already go through this.
On those topologies,
yes.
How do you separate the root ports? I mean, each head node, you show 4 head nodes there. How do you keep them from stepping on each other?
You mean, so you want to separate?
Well, with
separate
4 nodes,
yeah,
with 4 nodes, you can't have all 4 nodes trying to assign IP address ranges to the PCI devices. Right, you need each node needs its own root, needs to be its own PCI Express root. So do you partition the PLX chips?
Yeah, so I think that's where the CMC comes in, the management board that we have to manage the partitioning of the switch. So you can configure the switch, each one of the switch differently, be it a full fabric mode or point to point, or whatever the chipset allows, the switch allows.
Can the CMC card be the host? I mean, could you just run this standalone? Just put a Linux instance on the CMC and then have it send commands to the GPUs?
I think in the follow-on slides, I think we have the some details on the CNC.
Okay. All right. I'll wait.
Thanks.
Is there any reason that you mixed 1 and 2 and didn't just run them all at NVLink 2 in the GPU nest?
Oh, this is the demonstration. So it just shows how we so NVLink 2.0 is adding 2 compared to the version 1. So each GPU has 2 more lanes. So
okay.
A little bit misleading, but it just say we have for the 2.0 version we have more NVLink compared to the version 1. Yeah, I know. Okay. So next time we're gonna change the color. So it's a little bit misleading here. Yeah. All right. So, this we already go through the PCIe topology, and so for the onboard we have I2C topology. So there's I2C network between BMC. So we have the topology to all the GPU and PCIe, the VR, also the thermal sensor, etc. So I can will be on this one. So this is a CMC board, the side view, mechanical view. So we have a configuration table on the right. So the processor is using a Tom processor, the C250. So we have onboard DIMM slot. We support DDR3 memory. Also the OS feature support ECC. So we have booting joint using SATA M.2. We have Ethernet LAN, and we support USB and PCIe Gen 2 on this board. So this is a brief diagram of the CMC board. So this board will have some sideband management signal routing from the GPU board, from the BMC. So yeah, so any question on this one? Okay, so this is clock topology on the CMC.
I'm sorry, on that previous slide, the VGA comes from the BMC, right?
Yes.
So does that mean then that the Atom processor has to talk to the BMC to get its frame buffer?
I think it's just a routing from the BMC.
Yeah, you keep going. Okay.
Yeah. So this is I2C topology on the CMC board. Another special PDB board is responsible for the fan control and power distribution. So this is the end of the slides. So any question regarding this box?
How much power does it take?
I mean the whole chassis?
Yeah.
I don't have the data. I need to back and check. I need to get exact data.
Okay.
Well, USB one's like 300 watts times 8, 2400 max.
So the major power consumptions go to the GPU board. So for the CMC, I consume much less compared to that. So the power budget should be easily calculated out. But I don't have exactly number, so I need to check with backend team for exact
Is the
number.
voltage 12 volts single bus bar or 48 volts single bus bar?
It's 12 volt. So today's session is more on the the introduction of the product. So we are putting the specs together, and of course we have the original spec, but we have to convert it to the proper language and format. So we can share that, and then we'll have more details later on.
Okay.
Right. I think that's pretty much the scope of this solution. Appreciate your time. Thank you.
All right. So we'll put so Hong. I'm not sure I have your email, but we have Alfie's email. We'll go ahead and send questions to Alfie and ask him to help route those for us, so we can
sure.
get you.
Sure. Do send it to me, and then I'll loop in Han.
Okay. I think that those questions along the lines of power delivery into the OCP, server rack and draw. That's one of the things that this group has always been interested in, because the OCP rack specification doesn't provide a ton of or different options for high power or dense boxes. So definitely interested to see how this would play in that space. So do anticipate some questions there. Otherwise, we'll is it okay to send a pointer to the PDF out? I think I already did that. So maybe that's, if that's not okay, let me know.
Okay.
I did send it out to this user group so they could ask more questions for the people that didn't join.
Sure.
Okay.
That'll be.
All right, then let me see if I can. Any other dialogue on this topic? Okay. Then give me 1 second and I'll take the screen back and we'll look at the open domain specific architecture survey. All right, let's see if this, yeah, there it is. All right. So first of all, I have to send a reminder. We only got 9 responses, but of course, everybody that responded was interested. So Bapi, probably a little disappointed in that. And this was sent out to all of the OCP community. So let's see what the summary of those responses were. So interesting distribution of domains, coming back to look at it. Everybody, of course, interested, otherwise they didn't even take the survey. So if you want to scan through here, but it looks like there's a contingent that is not only interested, but fairly, have strong enough interest to join a separate track or project to discuss this. So that's good. So theoretically, of those 9 responses, 8 of them would join up, this call if we handle it in the HPC forum or an independent call. So there's the breakout of your survey response question. Fairly even distribution between the 3 primary roles. And the personal interest question. This was a multi-check box, so. Bapi, any comments or questions here? Is this what you expected? If you're on mute, we cannot hear you. All right, and then the final question shows a dominance of people that would want to put chiplets on silicon, or be involved with integration, apparently. So we'll run this for a couple more weeks. We'll put another reminder out to the overall group, and then meet to decide what you want to do about it. Okay. Any questions about this from the people on the phone?
Steve?
Yes.
Oh, my mic was muted this whole time, so sorry.
All right. Yeah, that was a little bit lonely without your responses.
No, I've been here from the beginning, from the start of the call, from when you. Thank you for doing this. It is a very interesting set of responses. How do I access them?
I'll look to see if I can add you to the, if I can add you here to this. And sometimes you can only, oh, I could do this and send it to you. How about
Perfect.
that?
Yep.
All right, good.
It looks good. I mean, it's like I was thinking there's some kind of Bayesian logic in terms of who responded. Okay, so we wait for what would you suggest as next steps?
We didn't have our meeting to discuss how to start to merge the IP, but I think that given that this forum doesn't have a ton of volume, we should probably invite the people on this list to the forum and start to work through it in a track conversation. And if you guys are committed on your side, we'll use the first meeting to go over what the contribution system is to OCP, and then engineer, see how that matches up with what the workshop has done, and then vote on how to go forward from there.
Okay, and the timing works out too. We have a workshop on Tuesday, so the timing should work out. We should come back with something tangible out of that.
Okay, great. Then that's what we'll do. I'll go officially add this as a track, and in our tracking documents, and we'll start to onboard with the checkpoints along the way to say, after you've been educated on what OCP is, then if you're still eager to go, we'll invite these people that have filled the survey out and start to form the community.
Sounds good. And we have a bunch of people showing up at the workshops. I'm sure we'll have more joins as well.
All right, good deal.
All right,
great. Okay, then the last topic, or the last potential topic was, Seth, you brought some things that I know that the one from the IoT and HPC didn't work out. We invited some people that potentially come to talk to us about that. Is there anything else that you want to throw at this group to bounce off of?
No, it just seems like I've been getting a lot of IoT stuff, but everything else is sort of, I think there's an interest in some cloud for making it easier to use FPGAs, but that still seems to be more of a vendor integration problem than just the players involved. Trying to make things more consumable, I think it's still a challenge. I'm not sure how to go about it. There's the esoteric software domain, as well as just can you make a mini? Can you provide access to find a way to buy things more easily with HPC? There are vendors out there like the ones on the West Coast who will sell you a rack of a small cluster. But even what we had last time with I guess it was a gentleman from a small company in the UVTV, whatever, he wanted like a desktop type of mini rack, HPC mini rack. I'm not sure there's enough demand to provide that, make it viable for the marketplace. So that's kind of what I've been trying to struggle the last 2 weeks, trying to figure out, is there enough demand to justify effort to grease the supply chain?
Yeah, I can't comment. I don't.
Yeah.
Anybody on the phone want to weigh in on this?
Well, who is that? I mean, who's your employer? The person who was speaking? I mean,
Oh,
what do you mean by grease?
So we want to enter the HPC as a market. We can try partnering with, let's say, provide like Nimbix or so, but there seem to be very few, I guess, market suppliers or integrated service providers, and they seem to be very small, niche. If let's say you would do it yourself on let's say Amazon, and that it becomes a little difficult because it just gives you the instances and you're up there on your own to put it together. your own management system, your own storage, your own bursty accelerators, and so it's never quite an easy access for someone. Let's say you're in, let's say, high compute for genetics or high compute for modeling geodetic data information systems. Those they seem to be very much proprietary, and so the market for HPC as a workload seems to be constrained to very small specialized players. I'm a
Well,
copyright.
yeah. I mean, if the market, yeah, if it's a
Yeah,
small market, then you know
yeah,
it's fed by small players.
yeah,
My employer is Penguin Computing, and I would point out we have our
yeah,
Penguin On Demand service, which is
yeah.
optimized for delivering exactly what you're describing. You know, HPC
Hmm.
resources, batch scheduled,
Yeah.
and
Hmm.
accessible with just a credit card. I mean, and
Hmm.
you don't have to set up a scheduler. There's a batch queues there.
Hmm.
You sign up and you upload your data, run your job, get your data back. You know, you can visualize it in the cloud. We've got all
Hmm.
that, but I don't want to be an advertisement for Pod.
Yeah,
Um,
sure. Yeah.
but uh, and what's interesting though, I mean, for this group though, is that Pod does actually run on open OCP hardware. We have when we added our Skylakes, the Skylake nodes are all OCP form factor in
Hmm.
a Penguin Tundra rack. They're 1U sized OCP nodes with 12 volt DC bus bars
Okay.
and the whole thing. So in that way, the OCP HPC is really embodied by what Penguin is doing in Pod.
Hmm.
It would be great to see other players adopt that, but whatever. Um, the having done that, the challenge for someone that wanted to do that again, if they wanted to stick with more mainstream Facebook-sized hardware, is that you don't get much density, and the
Yeah.
Facebook-sized hardware only gets you about 10 kilowatts in a rack. So you end up with, whatever data center you put it in, you start burning through floor space pretty quickly.
That was a
That's
complaint from USC. I think that's kind of the comment of those sort of smaller consumers who don't need like Facebook size capacity, but they still want the density, and they just have smaller space available, and they're trying to manage more than one generation of HPC systems. I think that
yeah.
that was a
Well, and
problem set they had from
yep.
like yeah.
And addressing the density is why Penguin developed the 1U form factor,
Hmm.
to be compatible with OCP, and why
Hmm.
we've come out with higher power shelves and yada yada yada. But again,
What is your power shelf? I haven't looked at it so far. What's your highest Sensei power shelf? Or
right
how,
now 26 kilowatts on 277 volt power, but we can put two of those in a rack, so we can
is it
theoretically get to 50 some kilowatts in a rack.
is it a three bus bar or one bus bar solution?
Three
Sorry.
bus bars,
Okay. All right.
because the nodes all plug directly into the bus bars.
Yeah, I have a
So
one bus bar system back here. It's 36 kilowatts. It's annoying. But
in two zones, two zones
it's
or
being
48
college.
volts.
It's 48 votes.
Yeah. So
One
there's
zone. Hmm.
Yeah, so for 48 volt, we want to get to 100. So
Yeah.
we're going to keep three bus bars and run 48 volts on three bus bars to get to 100 kilowatts.
Oh, here's my other question. I think the bus bar solution is kind of what I have sometimes painful with. I'm looking at my system back here in my lab, and it seems to be a lot of effort to get that interposer board working. And if I'm choosing between three and one bus bar, is there a better way that I can sort of architect this power solution one versus three? Because it's like there's a little demand. I have to pay more for my rack. My rack is like $4,000 for what I have right now uh, with the power solution.
Yeah, but you theoretically you make that up when you put nodes in the rack, because you're not buying power supplies with every node and
Hmm.
you're paying for less sheet metal.
Hmm. Maybe.
So at some density level, I mean, obviously if it's just one or two nodes, then you're not there
No.
yet. But
No.
once you get 2/3 full, the price point should cross over, and then the ROI kicks in the next generation. A bus bar is never going to be should never be incompatible. Of course, we just went from a 12 to 48 volt conversion, which made things incompatible. But but unlike the blade center chassis where you might get 1 or 2 generations, but then the vendor would go, oh yeah, sorry, you got to replace that chassis if you want to use these nifty new cards, right? A lot of the blade chassis whether from HP or IBM or whoever, didn't last as long as you would have hoped they would have. But
No,
theoretically,
I'm having.
a bus bar should last multiple generations, and you shouldn't have to incur that 4K cost for 5 or 6 years. Twice, at least one generation of machines, and hopefully 2 or 3.
I'm just having trouble consuming more than 2 kilowatts. Just the geometry of some of the devices in a 2 OU space. I'm just having trouble getting past a 2 kilowatt density. I'm not sure if it's because my procs I have right now 2 Power 9s. They're going at most they go 450 watts. If I take 2 V100s there, I get 600 watts. My SSDs aren't going to consume that much space, and then I'm out of space because I'm air cooled. Are you getting high density with liquid cooling? I think that's something we're talking about a while back.
Although our current liquid cooling solution limits us to about 80 nodes, 79 nodes or something, just because of the number of cooling taps. We could go higher with a redesigned cooling tap, but we usually run out of power before we get to 80 nodes as well. So we're pushing on all those dimensions, right, to increase that. Right now we're looking at a design optimized for Mellanox's new HDR, where we believe we can put 80 nodes in a rack with Mellanox HDR switches, a complete cluster solution with management, 80 nodes, 200 gigabit connected, with full bisection bandwidth.
How tall is the rack?
We could put that's a 48U rack.
Really, you can get 80 nodes in a 48U. Oh, okay, but you're splitting it. I'm sorry.
Well, it's only 44 OU, but it's 48 EIA 19. I mean, so it's the slightly taller data center rack spec, but it's not super tall. But we can fit 80 nodes. But and crucially, it includes 6 1U switches to make the full bisection bandwidth HDR topology, plus 2 gigabit switches to be management, or potentially multiple 10 or 25 gig switches to give you an Ethernet overlay for both management and data separate from the HDR. So that's kind of that's a drawing on paper. Not necessarily sure anybody would actually buy that, but it's reasonable, and it's it passes the first level sniff test. Smoke doesn't come out.
It's always good.
Yeah.
And to get to that, and we're also working with other customers that are looking at building really high power 1Us, right? So from either 12 or 48 volts, being able to put 3 kilowatts into one OU, is reasonable. And then we're going to run out of power well before we run out of space.
How many whips do you have to one rack?
Well, we try to keep it to 1. We try to keep it to 1. To get to 50 kilowatts, we would need 2, and those would be 277 volt or 240, 415.
So the issue we have here is that I only have certain maximum number of tap boxes I can hit in our data center. So I have to have an octopus. I have 4 whips to one rack right now to get myself to 30 kilowatts.
Did they limit you to L2130s?
I don't know.
Phase?
Yeah, I wonder if it's this way we do our topology because we have failover, but it's becoming annoying. But that's internal to us. Don't worry about that. So, but I think for everyone else.
But that has also, I mean, we also want to sell to enterprise HPC customers, and some of them, we had a customer went into a data center where the data center's like, yeah, totally, you can't, we reserve the right to take down either your A or B feed, 1 day a week. And so the customer's kind of like, yeah, no, I can't have my machines falling over once a week. So you have to install AB power. So we have ways to do AB power. It takes more space for more rectifiers and more power shelf.
Well, that's the problem I have, because we build it, our supplies always have an ATS built into it, and the cost goes up and the density goes down. But that's just because my customer's enterprise, and
Yeah.
I deal with that right
Well,
now.
yeah, and customers that need that are recognize that they have to pay for it.
Yeah.
So that's not usually a problem. But we're also bringing on some new rectifiers which provide AB feed capability, more flexible power options, and are denser than the ones that we have now. So they're about 30% denser, maybe 25% denser in terms of power per cubic inch. And so with those are the ones we think we'll be able to get all the way to 100 kilowatts in a rack.
Okay.
And so to get to AB at 100 kilowatts, that's going to be multiple 100 amp whips. And they're going to be eye-wateringly high power level, whips.
And thick.
Well, yeah, that's locomotive cable, was what somebody called it once. Yeah, it's like 6-gauge wire or better. But if you want one whip and one whip per rack, you can get a respectable amount of power out of a single 60 amp feed, and the 60 amp cables, it's not like you're wrestling an elephant or anything.
No,
it's not too bad.
I'm looking at them right now. So I'm looking at my racks right now. So it's just for my sake, is that we have legacy data centers that and putting in new power tap boxes and trying to get a new standard, because trying to keep it in line with OEM style racks, because that's where we put our racks, and it's always been a challenge trying to keep things uniform and manageable.
Yep.
So, yeah.
Right, so 24 inches in an OCP rack doesn't leave you with a lot of room for dense cabling. So we're looking at we've been using the open bridge rack spec, which is 28 inches. Most of the data center racks are either 24 or 30 though. So we're coming out with some 30-inch options. That way 4 racks fits in 5 floor tiles. So you can get back to a floor tile pitch. You're not always off. That sets off some people's OCD sometimes.
Yeah.
But and that gives us a number of options. But it then sours the density story a little bit. But if you look at it like a high-end Cray XC or something, if you were to buy a supercomputer from Cray, there would be a compute cabinet and then a liquid cooling cabinet and a compute cabinet and a liquid cooling cabinet.
Yeah.
And they talk about, we get 192 nodes in a rack. Well, yeah, except that you need another rack's worth of space that's just dedicated to plumbing and cooling and all the rest of it. So you really only got half that. You only really got 96 or so nodes in a rack, maybe, per floor tile kind of space. So I feel like we compete pretty well, on density. And by going to a bigger rack, it becomes much more serviceable, but we're also looking at other ways that we can reduce the amount of wiring we need, and for less dense solutions where we're not trying to run 3 network connections to every node. Hopefully we can get down to 1 or 2.
I'm stuck with 4. Lucky you, I'm stuck with 4 per node for redundancy. Yeah, so I'm kind of screwed that way. But we have customers who want high availability, so it's just because they are habituated toward 4 connections and redundancy. So
so then you're and that's where things like a 2U sized node kind of works out in your favor then, because it's not as dense on the cabling, and but then you're not so much into the HPC space either.
Not really. I think no, it just the cabling is a challenge, I think, overall with open compute. If you have high dense, you have need for high. If you need for HA, it does get kind of challenging.
Yeah, and we've had a few orders that have had just a ridiculous number of connections per node, and we can make it work. We've made it work. I have the pictures. I could make a T-shirt. But yeah, that's another thing where of necessity, you know, a Facebook rack, everything, they're always literally top of rack switches, right? But that means your cables have to go all the way to the top.
Oh yeah. Yeah.
And we have network shelves that we can distribute those switches all through the rack so that we can get really short cables, which is also important when you're talking 100 gigabit and you don't want to run, you know, a thumb-sized cable to maintain 100 gigabit speeds, and you just want to run a 1 meter cable, so you want to be able to use the smaller gauge wires. And we can actually connect quite a few nodes, you know, within the radix of a edge switch with just 1 meter cables. We can get them all to fit. So that tends to be a building block, is a network shelf with the edge switch in it, with the 20 to 40 nodes that are connected to it, or 20 to 60, I guess. When HDR comes out, if we do HDR 100, you do 60 nodes and 10 uplinks. That's 3 to 1. No, you do. Well, whatever. Anyway.
Yeah. Right.
Can I let me grab the screen one more time and
Sure.
talk about something that came up here. I think this is probably hitting the server group, but should be interesting to this group as well. So can you see my screen?
Yep.
So this is a open standards open specification for liquid cooled service racks. A lot of names here, for different people. They're going to different standards organizations now to garner support. Interesting when it comes to how this will intersect open compute. They're basically trying to get a standard manifolds and systems for plugging in warm and cold. I don't know how this is faring inside of open compute. The first question was, well, if this is only available for 21-inch racks, et cetera, they always had that question.
Or 19, yeah.
Yeah, and so I don't know if they've dealt with the bus bar question yet, and whether it makes sense to have, power and water on the same side, or what you do if you want to add bus bars, and now you have cooling coming into the back.
Actually, it works out better coming in. Well, this is a 19-inch server in this picture, because the power supplies are there in the back and the nodes are in the back. And this illustrates one of the disadvantages of this style, which is that you just queued up a PCI slot to get your tubes in and out.
Yeah.
I mean, I have a fair amount of experiences with this, because we shipped, I don't know, a couple thousand nodes with liquid cooling to the US government in an OCP rack. And we put the manifolds in the back. You connect the tubes, where the bus bars are. The tubes then exit the bus bar end of the node where there's nothing else but just air vents. So you don't block a PCI slot.
Okay, because the PCI is all coming out the front, right?
Yeah, because all the I/O is in the front.
All right.
So yeah, this is interesting. Can you put this in the meeting minutes or whatever?
Yeah, I'm gonna put it in the meeting minutes. I uploaded it to the drive, and there's that's why I just wanted to kind of do an FYI and show people, that this is getting shopped around, and let people weigh in. Maybe we'll spend a couple minutes on it next week or next meeting to talk about the pros and the cons, and I'll find out also where the main discussion in OCP is. I'm almost sure it's in the rack and server group, but I'll go contact those guys and make sure that see if they have any advice on how to participate.
Yeah, that would be
formally. Okay.
Yeah, because we do have quite a bit of experience, and we're bringing up a second set of technology for liquid cooling. So we'll be able to offer actually 2 completely different solutions, but they're all based on the same sled model. So we're already, sort of pursuing a path that says you could buy liquid cooling from vendor A or from vendor B, or theoretically from vendor C, and you'd buy the same server, configured the same way. You just have a different loop inside, and you'd have a different infrastructure outside the rack. But
Yep.
But the interface there and the sheet metal is all the same. So
Yeah, and I think this gets down to the plugs. Yeah, the quick connects, right? Because those having commonalities there is important for.
Did they design their own, or did they buy someone's? I wonder.
From what I heard of some of the vendors that had a vendor meeting on this, they used a who is it? It's a derivative of Schneider Electric. But one of the vendors I had talked to said that that was a common, a fairly common design.
Okay. Interesting.
So yeah, so down to the quick connect, and the goal here of the goal is infrastructure reuse. So if you buy a rack and manifolds, you can plug one server out and put the next one in, the next generation in. Right, they prefaced this meeting by showing some of the different, like Rankin has one circular tube of water that goes from the top to the bottom of the rack, in the center. The 2 manifold design is a lot more common, but or at least one manifold on both sides is common. So it's interesting that that they've made some choices here, but we can get into it more next time.
All right. Thank you.
Yep. All right. Anything about the summit, Phil, that we need to talk about?
Not that I know of. I haven't heard anything come up.
Okay. Then we'll go ahead and we'll bring this meeting to a close and continue the track overviews next week, or in 2 weeks. Bye now.
Cool. Thanks. Bye-bye.
Yeah.